Okay, this is June 2022 exam that we are going to consider. And in this platform, we are going to try by all means work out everything that you are given. So that is the total marks that you're given, what was a 75 mark question paper. So we are not going to waste much time for you guys who are writing the exams for mathematics grade 9. So definitely I understand that some of us, they actually have written, but for those who are yet to write, we can still have something to revise from this paper based on what you're going to have on the final. Just try to figure out how questions can be related from what we are going to revise. Okay, so this is what is important, guys. Consider that any degree of accuracy that you're going to have, if necessary, round off your answers to 2 decimal places unless otherwise stated. And also the diagrams are not necessarily drawn to scale, meaning to say that every diagram that you're given, do not measure because it's not given to scale. It's just a diagram that you're given there. All right, so we're not going to waste much time. Let us quickly rush through our questions we are given. Answer question 1 in section A by circling the letter next to the correct answer. All right, so you're going to put a circle. All right, then question 2 to 7 in section B in the spaces provided in this paper. So we are going to see that. Let us see question number 1, which is of section A. We are given answer the following questions. By choosing the correct answer, circle the letter next to the correct answer. So we need to choose the correct answer, then we circle that correct answer. Okay, let us consider what we are given on the first part. Complete. This is 2x plus y to the exponent of a 0. Any number, as long we are given a number raised to the power or to the exponent of a 0, that's a 1. So if you're given a bracket whether this is 3y plus z, everything, as long it's inside of the bracket, you're also supposed to obtain a 1. So meaning to say the one that we need in this case, this one is the one that we need, which is on C. So we are going to circle your answer on the letter C. All right, so that is what you're given. 1.2, written below are 2 statements about a number pattern. So these are statements that we are given. Okay, let's consider the statements. The first statement that you're given is the first term of a sequence is 8. So we are given the first term. 2, the constant difference of the sequence is 2. So there is a constant difference as you are moving from one term to another, whereas 8 is the first term. So this being an arithmetic type of a sequence that you're considering a pattern, where there's a constant difference of 2 from one term to another. If the first term is 8, to get to the next term, you must add a 2, and so on. And so you're adding a 2 on each and every term. There is a constant difference. So the question is, which of the following sequences agrees with the above statements? Which of these sequences it agrees with these statements that we are given? Okay, the first term being 8. Like I said, there is a difference of 2, which is constant. So you're going to add a 2 to this number 8. So if you add a 2, what are you going to have? 8 plus 2, that is a 10, which is the next term. So you're simply adding a 2. You add a 2 here, which is the difference. 10 plus 2, that is a 12, and so on and so on. So if you check, the correct answer is supposed to be on this one, on D, where we are given 8, 10, 12, and so on. So this is where we are supposed to have our correct answer, which is D. It's going to be and so on and so on. You are adding a 2. All right. Then we are given 1.3. Given the expression, so we are given this expression. From this expression that we are given, the coefficient of M is. What is the coefficient of M? Remember, the coefficient is the number that is affecting a letter. The coefficient of a letter X is 3, the number that is affecting X. So the coefficient, we need where there is M. Take note. So this is where we have M. So the coefficient of this M, we are considering the number that is affecting the M, this number here. So it's a +5. That's a +5. So where are we having a +5? That is on D. Just like that. So guys, you need to revise as much questions as you can before your exams. All right, 1.4, determine the value of this. Okay. So there we are supposed to apply our board mass. Okay, remember your board mass, brackets of. So are there brackets? Yes, there are brackets here. There's a bracket that you're given. So simplify what is inside the bracket. Guys, you can even use your calculator. That is 3 minus what is inside of the bracket. That is -5 plus 2. -5 plus 2, that is a -3. So since there is a sign, you're going to just write it as a -3 inside of a bracket. So we simplified what is inside of a bracket, but since there is a sign, whenever you're given two signs following each other, it is important that the second one, you put it in a bracket. 4 minus plus a 7. It is important that you put the second one in a bracket. So it's like we wanted to clear a bracket, but as we are doing that, there is also a law which is guiding us there to have a bracket. Yes, you can write just 3 minus minus. It's fine as long as you understand what you're writing. Then there is a +3. So let's consider the sign, the minus and the minus. Remember, when two signs are the same, they combine. These two signs are the same. So that is going to give us a plus. So meaning to say we are going to have 3 plus a 3 plus a 3. So there is no longer something like, there's nothing like board mass now. It's just addition that we are having. So you're just adding everything. 3 plus a 3, that is going to be a 6 plus a 3, which is a 9. So the correct answer where we have a 9 is on B. Just like that. So this is what you're supposed to have. You're supposed to apply your board mass. Guys, just use your calculator at once. Still, you can get the answer. This is exam. This is just 1 mark. So instead of us using a board mass, so this is, okay, let me show you. If you are to use your calculator, direct, because some of us, we also have a challenge when it comes to the use of a calculator. So I want you to be careful also on the use of a calculator. Okay, so let me try to have the calculator so that we can see. So this is 3. So you're going to have 3. So take note. The first one is the minus. So this is the minus. Okay, so you're going to have minus. Then you open the bracket. This minus on a 5 is the sign which is affecting the number. So is this one in a bracket. So if you check on your calculator, there's a minus in a bracket. You press that minus, then a 5, then +2. That means you're adding a 2. Close the bracket, plus a 3. So that is going to give us a 9. So as we can see, we could have simplified this direct on our calculator. All right, 1.5, you are given for which value of t is t over 2t minus 2 undefined, for which there is this term that you're given undefined. What does it mean to be undefined? Remember, to be undefined when working with a fraction, it is on a condition when a certain function that you are given, let's consider it is x, it is y, whatever that you're given, is divided by a zero, considering a fraction. This is undefined, does not exist. If you take your calculator, you divide any number that you want. Okay, let's just use numbers on our calculator. 5 over a 0 like this. What are you going to have? That is math error. This does not exist mathematically. It is undefined. It does not exist in our mathematics. So if the denominator is a 0, it means the fraction is undefined. If the denominator is equal to 0. So you're going to take your denominator and equate it to 0. For this fraction to be undefined, 2t minus 2 is supposed to be equal to 0. Thus, you can solve this equation. It's an equation, okay, that you can solve. So I'm going to go back to the another way. I'm going to go back to another way so that you understand, okay? So this is it. You're going to solve this. Remember how you solve your equation. You take this to the other side of the equation. The moment that it crosses the equal sign, it changes the sign that you're given. So this one, it was minus. It becomes a positive. So 2t is equal to a plus 2. It's now a positive. Okay, so what are you going to do? It's a product here that you have. So the opposite there is to divide to remove a product. So t is equal to a 1. Okay, so meaning to say when this is equal to a 1, this is undefined. Okay, in an exam, you are in an exam and you do not you do not understand the solving part, but you understand that something that is undefined, it is something that does not exist, whether it's a fraction, whatever that you're given, mathematically, it does not exist. So on your calculator, you must have this presentation of the math error. Let me just put something that does not exist mathematically, like 1 over a 0, like I said before. It must write this. If you see this on your calculator, it means that is undefined. So you can test using the values that you are given here. You just start with a 1. You put a 1 wherever there is a t. So on your fraction, that is a t. So it's going to be 1 over 2t minus 1, that is 2. You open a bracket for a 1 like this, minus a 2, then is equal to. So as you can see, it is giving us a math error to show this does not exist. So you know that when this t was a 1, which is this value that you substituted, this is undefined. So you can even try to another value, which is 2. You put a 2. So in this bracket, we're going to remove this, put a 2 on top. We're going to put a 2 in place of wherever there's a t, you put the value that you're given. So as you can see, it gives us an answer. So meaning to say this is defined. We want where it is undefined. So this is what you can do if you do not understand. Wherever you get a math error, that is to show it is undefined. So you move again, minus 1. When this t is minus 1, in place of this, you substitute a minus 1. On top again, you're going to put a minus 1. As you can see, you're going to get a 1 over 4. Just to get an answer like this, it is defined. So we do not want that part. We want where it is undefined. So we put a minus 2, which is on D. There's a minus 2 there. So you're going to put a minus 2 Our answer is 1/3. It is defined. But if you check when we substituted this one, the calculator showed us a maths error, that is to show us that it is undefined. So you can do that, test your values if you do not want to solve the way that we had of the of using the denominator. Okay. Question 2 on 2.1. The following table shows multiples and factors of 30, 75, and 100. Okay. The factors 1, 2, up to 30. The number is 30. The multiples. Okay. So we're just given like, okay, let's see. What are we given? So the question is on 2.11, write down the highest common factor, which is the HCF of 30 and 75. Okay, so remember, we can determine the highest common factor by seeing the factors of these numbers. We are looking into the 30 and 75. So where are we having the highest common factor? The biggest number which is common between these two numbers. So you can check from 1. As you can see, 1 is common, but is not the highest number. Okay, 3 is common, but is not the highest. 5 is common, but it is not the highest. 15 is common. So let's check 15 here. This is the bigger value that we have, because 30, we do not have 30. Here there is 25. So it must be common, but we need the bigger value that is common between these two numbers. So the bigger value common is 15. That is our highest common factor. Okay, that is our highest common factor. All right, let's consider this one. The lowest common multiple of 75 and 100. We need the multiple. So you consider this one, but it must be the lowest, the smallest multiple between 75 and 100. We consider this side of the multiples, but the smallest multiple, which is common between these two numbers. So let's check. Is 75 common? We do not have 75 here. 150, we do not have. 225, we do not. So you check which one, the smallest one that you're going to take, which is common. So if you check the smallest number common, it was a 300. There is also a 300 there. This is the smallest number common on the multiples. So we need the lowest, the smallest. That is the idea. That is common between the two numbers, between 75 and 100. So the smallest number common there, it was a 300. That's how you take it. Take note. The highest common factor, you consider the bigger value that you are given, the biggest value that you are, which is common on the factors, the biggest value, which is common. Okay, that is the idea that you can use. Meaning to say, if we wanted to find the highest common factor of 75 and 100, let's say we wanted to find the highest common factor of 75 and 100. You were going to consider where the factors are, but considering 75 and 100, the biggest value common, the highest common. We cannot take a 1, we cannot take a 5, so we move on. A 15, a 25. 25 is common. Okay, 75, we do not. So if you check, 25 is the biggest value common between a 75 and a 100. 25 is the biggest value. So in this case, the answer was going to be a 25. So guys, you can answer any question. I'm just assuming, let's say it was that between these numbers. All right, so these are the answers that you're supposed to have. 2.2, the cube root of 15. There's a cube root. So the cube root of 15 is between which two consecutive whole numbers? Okay, so what is the cube root of 15, guys? This is, if you do not know, just use your calculator like this. I want you to understand this idea so that you can simply get your answer straightforward. The cube root of a 3, we can check here. We can go straight to the cube root, which is shift on this one. It gives us the cube root of a number. So the cube root of 15 is equal to 2,4, something like that. Okay, so let us just fix this to 2 decimal place. That is 2,47. So if you check, the cube root of this number 15 is something like 2,47. This is the cube root, like the cube root of 15. Okay, sorry, we are here. The cube root of 15. The cube root of 15 is something like 2,47. So guys, if you understand this, 2,47, it is between which numbers, consecutive whole numbers. On a number line, if you consider a number line, this is 0, 1, 2, 3, 4, and so on and so on. 2,47, it's a value that is bigger than 2. It's bigger than 2. So maybe we can have it somewhere here, somewhere there, 2,47. But this value is smaller than 3. It is in between 2 and 3. 2,47, it's bigger, it's above 2. It's more than 2. Guys, it's 2. There's a 2,01. There's a 2,2, 2, up to 2,47. So these are values which are more than 2. 2 is a whole number. So meaning to say, we are talking about 2 and 3. These are the whole numbers where we are going to find this cube root of 15. Then 2.3, is this cube root of 15 rational or irrational? A rational number is one that can be expressed as a fraction where a and b are integers, whole numbers. But this is not it. 2,47 and so. So this is not. So it is an irrational number. So that was going to be an irrational number. Okay, so that is what you're supposed to have on 2.2. So these are the typical questions actually that you are going to be given, and you need to relate to the information that you are given, that you have calculated before. 2.4, we are given, determine which one of the 4 tables given below. So we just need one. Which one of the 4 tables given below represents direct proportion? Justify your answer. A direct proportion is where we have, remember, X is the input and Y is the output. So what happens is that a direct proportion, it is considered this way. If you are to consider Y is proportional to X, which is the input, it is proportional to what you have on the input. This is the output. This is the input. So if Y is proportional to the input, which is X, it means Y is equal to the constant times X. Remember, X is the input. So it follows that if I am to divide this by X, divide by X, okay, I am going to obtain a constant. Y over X is equal to a constant. So that is wherever I divide the output over the input, I'm supposed to obtain a constant. So sometimes you can even use X over Y. It's fine. But from the actual way, you can use this consideration. Okay, so let's consider to say we are supposed to obtain a constant throughout these divisions. Let's consider the table A that we are given. We need just to divide Y over X. Yes, you can divide X over, as long as it gives you a constant. That one, it does not affect at the end. So you're going to divide, that is 5 divided by 4. 8 divided, 15 divided by 8, 20 divided by 12, you see that the values that you're going to obtain there are different. You're obtaining different values. Okay, let's do this. This is just gonna take this to the normal mode so that we see what you're going to have. Maybe they are fractions or what. So let's say 5 over 4 like this. That is gonna be 1,25. Okay, let's divide the next one. 15 divided by 8, which is 1,8. Just that these two are different. Move on. Move on to another one. We are supposed to have exactly the same throughout. So this is totally different. Let's move on to the second table, B. We consider this part that is 6 2/3. So to have this one, it's going to be shift. You press this. So this is a fraction 6 2/3 like this. So this is supposed to be over a 30. So I'm just going to use a division because I've already used the other way. So it's going to be 2/9, which is 0,22 and so on. Okay, let's divide the second one, 4 and 50. 4 divided by 50, that is different, 0,08. This is totally out. Okay, the same thing. So you do the same thing throughout. Let us move on to table C. On table C, let's divide 12 to 3, 20 to 5, and so on and so on. So let us sim 12, sorry, the first one, that is 12 divided by 3, which is a 4. Okay, 20 divided by 5, that is a 4. 32 divided by 8, that is a 4. 48 divided by 12, that is a 4. So as you can see, throughout you are obtaining a 4. So the table C is the one that is for a direct proportion. We are obtaining a constant y over x is equal to a constant value. So like I said, you can even use y or the other way, x over y. You're going to have the same thing. If you are to use that, this one, it gave us a 4. If you are to use x over y, you're going to obtain 1/4 throughout. 1/4, 1/4, 1/4. As long that is happening, that is a direct proportion. So I want you to prove B and C if not, but you're going to see that D is not going to give us what we want. On 2.5, we are given, this is important when it comes to our ratios. It takes Sandile 6 hours to fill 1 tank with water. So take note, this is Sandile. She is to fill a tank 6 hours, 1 tank. This is 1 tank, full tank. She takes 6 hours. Working alone. Jacob needs 12 hours to fill the same tank with water, working alone. So Jacob needs 12 hours to fill the same tank, working alone. So the question is, if Sandile and Jacob work together to fill the tank, how long would it take? Give your answer in hours. Okay, this is already in hours. I want you to understand this type of a question. It is very, very important. So this is what is happening, guys. You consider to say, Sandile, she is filling 6 hours. She takes 6 hours actually to fill a tank. So let's consider a pace where they work per hour. When they are working per hour, both. Sandile, she is to work 6 hours to fill this tank. What about per hour? If 6 hours is equal to 1, it's a proportion now. 6 hours is equal to 1. What about 1 hour? In an hour, how many parts of the tank she is going to fill? Because 6 hours is a full tank. So 1 hour is like how many parts of the tank is she going to fill? So that is going to be a less. So that's 1/6 times 1. So that's 1/6 times 1. So meaning to say she's going to fill 1/6 parts of the tank. 1/6 parts. So it's like a tank. It is made up of 6 parts. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. So the tank is initially, for this one who is working with 6 hours, we are considering, according to her pace, the tank is made up of 6 hours according to her pace. So meaning to say an hour, it's 1 part, an hour, 1 part. So she's going to take 6 parts, 6 hours to fill each part. Each part of the tank, it's an hour, which is 1/6. There are 6 parts. So 1 part of the tank, just to fill 1 part of the tank according to a pace, just to fill 1 part of the tank, which is made up of 6 parts, it takes an hour. So you divide the tank in terms of hours. 1, 2, 3, 4, 5, 6. That is how you can answer this question. Meaning to say she's going to fill 1/6 parts of the tank in an hour, per hour. The same with what is going to happen with a Jacob. According to Jacob, he needs 12 hours. So we are going to divide this tank according to 12 parts. That is what we're going to have. So meaning it's just going to be one and the same. So Jacob is going to need 1/12 of what is having. So Jacob per hour, it is going to be 1/12 of the tank. So according to his pace, it's like the tank is divided in 12 parts according to his pace per hour. So Sandile has filled 1/6 of the tank. Jacob has filled 1/12 of the tank according to his pace. He has filled 1/12. So what is going to be the total together for these two guys per hour? We need to, their total, this is per tank, because as we can see, we cannot tell how many parts is this tank, because according to Sandile's pace, the tank has got 6 parts. According to Jacob's pace, the tank has got 12 parts. It is made up of 12 parts. So together, we can now combine and see how is this tank made up of, how many parts when they are working together. So meaning to say in an hour, we are still per hour. So it is going to be 1/6 of Sandile plus the 1/12 of Jacob. So just use your calculator. You are going to obtain 1/4 if you simplify this properly. So now I want you to understand what it means. Now I want you to understand what it means. This is when they are working together. The question is, let us consider our question. We need, when they are working together, how long it take, how long with the time. So this together here, it is 1/4 parts of the tank. When they were working separately, you consider this one has got 1/6, this one has got 1/12. But together now we can see, okay, this is how the tank is made up of. So this tank is like this. This is the tank. They are working together now. So we want to see how many parts are we having on this tank. So this tank is made up of 4 parts, the denominator, 4 parts. So this is what is happening, guys. 1/4 parts, it means an hourly taken in an hour, just like what I used on that part, if you still remember when I was explaining about 1/6 of Sandile. They are working both together per hour. So it means in an hour, they are going to cover 1/4 parts. So it's like, this is an hour, they cover one part. Another hour, they're going to cover one part. Another hour, another part. Another hour, and until they finish 4 parts of the tank. So it means together they are going to take 4 hours to complete or to fill up the tank. One out of 4 parts of the tank, they fill together in an hour, 1 out of 4. So if you understand this, you can also take it as a proportion to say, in an hour, they are filling 1 out of 4 parts. So the tank, it has got 4 parts. The tank, a full tank, it has got 4 parts. A full tank which has got 4 parts. We want to know how many hours are they going to fill a tank which has got 4 parts. But 1 part of the tank, together they are filling it in an hour. 1 part of the tank, they need 1 hour to fill together. So in 4 parts of the tank, how many hours are they going to need? So it's a proportion, as you can see. You can also introduce that of x to say, let this be equal to x. So what I want to calculate, I can relate it to be equal to x as an equation. I can even form an equation. 4 over x is equal to 1 over 1, or 4 over 1 is equal, guys, the way that you want. You can even obtain the same x to be 4, which is 4 hours. So they need 4 hours working together to fill this tank. They can take 4 hours. So as time goes on, it's only that we never had, the way I'm explaining is because we never had like this topic covered separately. But as time goes on, we're going to talk about this. We actually do not need all this. If you understand from the introduction of the topic, you actually do not need to have all this. But we're gonna see as time goes on. We're gonna try to provide time for that. Question number 3, 3.1, which type of numbers in the number system are defined by the following? Okay, let's see. Numbers that extend the natural and whole number systems by including the operation A minus B, where A is less than B. Which type of numbers are these? Considered to be natural and whole, but including the consideration of A minus B, where A is less than, meaning to say they include a number where maybe A is 1, B is a 3. A is supposed to be less than B. So 1 minus 3, A minus B. It means also negative values are included, values such as minus 2. Positive values are also included. So what type of numbers are these? These are integers, positive or negative whole numbers. So you're considering integers. 3.2, the following statements are incorrect. These statements that we are seeing here, they are incorrect. Write down the correct version of each statement. That is, we are supposed to write the correct statement. 3.21, the cube root of minus 64 is not equal to minus 8. This is wrong. What is the cube root of minus 64? The number that multiplies itself 3 times to obtain a minus 64. That's minus 4 times minus 4 times minus 4. So the cube root of minus 64 is minus 4. You can also use your calculator for that. Minus 4 minus minus 6 is not equal to minus 10. That's what they are saying. What is the correct answer? Minus and minus, remember, it gives us a positive, like I said before. That is going to be minus 4 plus a 6, which is a 2. Okay, 6 minus 4, that is a positive 2 at the end. The square root of minus 9. This is 3.23. What is the square root of minus 9? Guys, the square root of minus 9 does not exist mathematically. It is undefined. On your calculator, the square root of a negative number does not exist. That's a maths error. So that is a non-real number, does not exist. Okay. -5 to the power of 2. The minus is raised to the power, so it's going to be a positive 25. So like I said, guys, the calculator is there. Use your calculator to prove this. Put a bracket as it is, a -5, close the bracket, raised to the power of 2. That is going to be a positive 25. As you are obtaining that answer on your calculator, that is exactly what it was supposed to be, not a -25. Okay, so they are actually saying, guys, you must correct yourselves, because some of you guys, you make mistakes of writing these answers. So they are saying, guys, correct yourselves. Are you able to correct yourself? 3.3, calculate the following. All right, so there we are given 5 into -2 squared. So there again, the board mass is supposed to be considered the brackets of division, multiplication, addition, and subtraction. They are brackets 5. It is a product. So it's just like 5 times -2 squared. That is a -2 times a -2. Negative and negative, remember, that's a positive. 2 times 2, which is a 4. A negative, when raised to an even, whenever you are given a negative like this, being raised to an even exponent, as long the exponent is even, it is going to be a positive. So if you're given a certain number here, which is 2, that will be a positive 2 to the exponent of that power that you're given. So this is the idea that you're given. So if you understand that, guys, that is fine. So that is 4 in this case. Then we're given a minus, that is a minus there, but these two numbers, they are dividing. There is a division of the two numbers. 15 divided by 3, which is a 5. Okay, the product, 5 times 4, that is a 20, then we subtract a 5. 20 minus 5, that is a 15. So in this case, you are going to obtain a 15, 3 marks for that. All right, 3.2, 3.32. Again, it is to simplify. Remember, negative, we are supposed to obtain a positive in that case. So meaning to say, this was going to be 2 minus and a minus, that was going to be a plus 4. Okay, -2. There is a bracket where we are given 1 minus 4. And 1 minus 4 is equal to what? A -3. So this is a -3. Everything over 1 minus 4, which is -3. Okay. According to this, we can see that this is going to be a plus. We agree, as you can see that, add. So 2 plus, you can add that, guys. If you want to say, okay, there's a bracket there, let me just remove, let me just contain my positive. It's fine. You can leave that. 2 plus a 4. So you're going to have something like this. 2 plus a 4. Then you consider, okay, I want my brackets first. Minus times a minus. That is going to be a plus. 2 times 3, which is a 6. Everything over 1, -3. Then you can add everything. 2 plus 4 plus 6. It's up to you. 2 plus 4, that is 6, plus 6, which is going to be 12 over -3. So this was going to give us a -4 at the end. So 3 marks for that. Guys, that's a lot in exam. Just to lose these marks, it's not as easy as it can be. Let us revise as much questions as we can. 4.1, the exponential form of 25 is written as 5 squared. What does the exponent tells us? Like, what does the exponent define? They're like, define the exponent, but in terms of what you're given. So it's like, how many of the same factors they are in the product of 25? Like the product of 25, how many factors? This is how we are simply having there. How many So you can just have it this way. How many of the same factors? These are the same. Remember, 5 times 5 times 5. Same factors. Okay. They are in a product. That is in a product of 25. So how many? It's just 2. 5 times 5. 5 squared. Okay. 4.2 represent the following statement in exponential form. 7 to the 50 power. 7 to the 50 power. The power is the 5. Okay. 4.3, rewrite the following expressions with positive exponents. Leave your answer in the simplest exponential form. 4.31. We are given 3x to the exponent of a negative 2. Remember that when given a negative exponent, we write it as 1 over. If it is x to the exponent of negative n, it's 1 over that. So what is being raised to the exponent of a negative? It is the x, not the 3, but this x. It is the one that is being affected by the negative exponent. So meaning to say, this is going to be 3 over x squared. The x is the one that is affected, not the 3. Okay? 4.32, 2 over 5 to the exponent of a negative 2. So again, just like the previous case, this is having a negative already. So to write it on top, it will be carrying a positive exponent. So it can be written on top as 2 times 5 to the exponent of a positive 2. This is what you're going to have. 1 over x to the exponent of negative n is equal to x to the exponent of n. So the question was to rewrite this with positive x, just to rewrite. So you can just leave it like that. It has got a positive exponent. Leave your answer in the simplest exponential form. This is the simplest exponential form. So do not combine whatever that you're given. Sorry for that. Very sorry for that, guys. So do not combine. Just leave your answer as it is. Simplify the following fully. So there we are given terms that need to be combined using our laws of exponents. A number that is being raised to the exponent of a negative. Remember, I talked about a negative when raised to an even power or an even exponent is going to change to a positive. But take note that every number will be raised to the exponent of 2. From the 5 that you are given, which will be a 25, the w, which will be w squared, the z, which will be the z squared. Remember, the negative to an even exponent, it will be a positive. So we no longer have that negative, okay? Then this is a product of a bracket which is just raised to 1. Being raised to 1 is just a product as it is, guys. There's nothing that is going to affect. Everything is just going to remain as it is. So this is over 50w to the exponent of negative 1 times z. Okay, let us consider the product of the terms, the 25 to the negative 2. That is going to be a negative 50. Then considering the w and the w, we are multiplying the bases, which are the same. So we are going to add your exponents. So that is w to the exponent of 2 plus 2, which is a 4. Same thing on the z. The bases in this case are the same, the z and the z, but this is to the exponent of 1. So that is z to the exponent of 2 plus 1, which is a 3. Okay. Everything that you're given over 50, w to the exponent of negative 1, z, which is same as z to the exponent of a 1. So guys, these two terms are the same. Just cancel them. That's going to have a negative. So this time you are dividing the bases, which are the same. What are you going to do? Subtract the exponents. That's 4 minus the exponent of minus 1. This exponent is carrying a negative already. There's a negative already. So minus and minus, remember, that's a plus. So that's w to the exponent of a 5. Okay. Then you move on to the z. Again, you're dividing the bases, which are the same. So there you have to subtract your exponents. That's z to the exponent of a 3 minus a 1. 3 minus 1, that is going to be a 2. So that's z squared. So this is what you're going to have at the end, minus w to the exponent of 5 z squared, just like that. So you have to be very careful, very, very careful. 4 marks for that. Question 4.42, we are given, again to simplify, that is 81 to the exponent of this. Okay, so I said before, try to write these numbers in the simplest form in terms of the prime numbers of the simplest form. 81 can be written in the base of 3 in the simplest form, that is 3 to the exponent of a 4. So you can even try 3 to the exponent of 2, 3, until you obtain this 81, 3 to the exponent of 4. But there is an exponent already of x plus 1 that you're given, multiplied to 5 to the exponent of 2x minus 2. Then everything there is being divided. 3 to the exponent of 4x times 25. Remember, we talked about this before. 5 squared gave us a 25, you still remember? So that is a 5 to the exponent of 2 times x, which is 2x. Considering that we have got the bases which are the same, I'm considering the base of 3, same base. Dividing, we know that we are going to subtract the exponents. We are dividing. So considering that you are dividing, what are you going to do? You're going to subtract the exponents. Sorry for that. So this is going to be, actually you can combine this part here, multiply at the same time. That is going to be 3 to the exponent 4 times x, that is 4x, 4 times 1, which is a 4. But subtract this exponent of the denominator, which is the minus 4x. We're going to subtract. Okay, let us consider the base of 5. So guys, let's hope it's not going to affect me, because these softwares, they tend to misbehave, you see. So there we're going to subtract again. The bases are the same. So that is 5 to the exponent of 2x minus 2. We subtract the 2x in the denominator. So that was going to be, if you are to subtract here, you're going to see that the 4x and the 4x are the same. So that's 3 to the exponent of a positive 4 times the same thing, the 2x minus 2x are the same. So that is going to be 5 to the exponent of a negative 2. So this is what you're going to remain with. But remember what we talked about before about the negative exponent. Whenever you're given a negative exponent, it means 1 over that. So this is same as 5 to the exponent of 2 in the denominator, which is 3 to the exponent of 4 is 81. 5 to the exponent of 2 is 25. That is 5 times 5. So this is what you're going to have at the end. So guys, for 5 marks, it's fine. Okay, so this is what we had on question number 4, which is having a total of 18 marks. That's a lot. In exam, you're supposed to obtain these marks. Question number 5, 5.1, examine is just like study. Whatever that you're given, first you have to study it. The first 3 diagrams in the sequence of diagrams given below. So study this, examine this. What are we given? The first diagram is something there's like there are triangles. We do not know. It's like we are working with these dots. We do not know exactly, but there's something that we are working with. Oh, it's like the triangles. Okay, so let's see. 5.11, complete the table by determining the number of points of intersection in the next two diagrams. So we are not working with the triangles formed. No, we are working with the number of points of intersection. That is what you're given. This is what you have to study. You have to study that. So according to this is what you're given. These are the ones that you're given, the intersection 1, 2, 3. So already they are giving us on the table the first one, which is 3. So if you count these ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the ones that we are given here. So the same, if you to count those ones, you're going to obtain a 27. So instead, the question is, complete this table. As they are moving on, there's going to be the next one, the next one. What are we going to have? Remember, we talked about relationships when considering patterns. Is there a relationship that can be considered between the terms? All right. If you were to consider the first one is 3, the second one is 12. What is the difference between these two? Let's say you were to consider first by the difference 12 minus 3. There is a difference of 9. 27 minus 12. There is a difference of 15, which does not make sense to our normal differences because we are supposed to have something which is common. We are supposed to have something which is common, like the same difference throughout. But in this case, this is not what is happening. As we can see, this is not what is happening. What is happening? 3, 12, 27, these numbers, they are important values. Like if we are to consider, there are two things. One, the differences which are thereafter. The differences which are thereafter. There can be two differences at the same time, or they can be a product. So let's just hope you understand. So I want you to see this. The first one, we are having a 9. Then the second one, you are having a difference of 15. Okay, what about here? What is the difference between these two? There's a difference of 6. Okay, let's add that difference of 6 here to this term. Let's add that difference of 6. Meaning to say 15 plus a 6, that is a 21. You add to the 27, this 21. 21 plus 27, what are you going to obtain? That's a 48. So it's like the difference first of this 6. Again, we are having that 6 again. It's common now, 6 that. So you add the 6 here to this 28, to this 21 here. 21 plus 6, which is going to be a 27. Then added now to the 48, that is having a 75 and so on. So this is how you can play around. So this is later explained. We're going to talk about this as a sequence which is considered as a quadratic later on as we move on with our mathematics, as we are in grade 11 and so on. But in this case, it was to study this. You complete by studying what you're given. What is it that is happening on our table? That is how you're supposed to answer this type of a question. Then the question was to describe the relationship between the position of the diagram and the number of points of intersection in your words. Okay, this was the first one. So if you had to consider this, it can be difficult for you to explain this one. Okay, let's consider another way. Like I said, there are so many ways that you can consider this. All right. I want you to see another way that you can consider this. You can study again. 1 is giving us a 3, okay? 2 is giving us a 12. 3, a 20. There's something that is happening. This one, if multiplied by a 3, 1 squared, it is going to give us a 3. We need to study like what is happening. 2 times 2, that's a 4. If you multiply it by a 2, by a 3, let's see what is happening. 2 times 2, that is a 4, times a 3, which is a 12. Are you seeing what is happening, guys? You move on to this number 3, you square it. 3 to the power of 3, that is 9 times 3, which is going to be 18, which is going to be 9 times 3, that will be a 27. In the same sense of this 48, we are going to have it the same way, 3 into a 4 squared. 4 squared, that is 16 times 2, which was going to be a 48. You move on to the 5, 3 times 5 squared, which is going to be 25 times 3, 75. So as you can see, we could have determined these numbers this way, and this is the easier way that you can actually explain than the first one. So there are 2 ways, as we saw. First one that you can like study what is it. It's like, how can you study it, guys? There are direct sequences that we are used to, but this one is not as direct as we are used to. We have to consider this. So according to this, it is easier because we are seeing that these numbers that are being squared, 1, 2, 3, 4, 5. These are the numbers 1, 2, 3, 4, 5, which is what? The position of the diagram. So is the position squared. So we are going to have the position squared. Okay, but after every position being squared, it is being multiplied by 3. Every position being squared is multiplied by 3. So, and multiplied. So this will be multiplied by 3 and multiplied by 3. That is the condition. So it's the position squared and multiplied by 3. So that is what they want you to describe. So I just hope we are together. I just hope we are together. Numbers are arranged in the following pattern. If the pattern is extended, what will be the 5th number in the 100th row? The 5th number. Let's try to study what is happening. Row 1, 22, 23, 24, row 2. It's a continuation, guys. Okay? Same difference throughout. So meaning to say it's just a continuation, like that is what is happening in this case. 25, 26, and so on. But when you're considering in terms of the rows, what are you obtaining in terms of the rows? Because they are saying numbers that are just arranged. So if the pattern is extended, what will be the 5th number? So this is row 1, 1, 2, 3, 4, 5 of row 1. Row 2, 1, 2, 3, 4. This is the number. Row 3, and so on. So we are going to have this. They are saying the number that is going to correspond, as these rows are correspond. There is row 4 here, there is row number 5, there is going to be row number 6. These numbers are going to form a pattern as the rows are going down. These numbers in the 5th, which will be the 5th number, like the 1st, 2nd, 3rd, 4th, the numbers which are on the 5th position, these numbers, they are going to form a pattern up to where we have row 100. We need to know what is going to be the number in that row 100 on the 5th number. So as these numbers are forming a pattern, what type of a pattern are they forming in the 50 number place where they are connecting in this 50 position? In the 50 position, we are forming a sequence. The first one of the first row, it was 25. Okay. Of the second row, the 50 number is 31. The third row, the 50 number is 37. So we want to know, like, this is the first row, this is the second row, this is the third row. So on the 100th row there, what is the number? So if you are to count, guys, up to 100, you can do that. But this is not supposed to be like that, because these numbers, 25, 31, 37, they are not just normal numbers. They are forming a sequence, an arithmetic, where there is a common difference, as you can see, between these two numbers. 31 minus 25, like second term minus the first term, there's a difference of 6. The third term minus the second term, there is a difference of 6 again, which gives us an arithmetic. Remember, I talked about the formula of the Tn equal to, where we're going to have the difference times n. We remember when I was talking about this difference times n times this. So guys, I want you to understand this. Instead, guys, of having this, guys, now we are used to this. So I want you to take note of this formula. I want you to use this formula. Tn is equal to the difference. So I just want you to use it as an or bn plus c. Okay? Or you can use it n plus any letter that you want. Any letter that you want. Any letter that you want. So you can use it as b n plus c, as long you understand that this is going to represent the difference, the common difference, the constant difference. So the constant difference is 6. So Tn is equal to 6n plus c, where c is the constant to be found. This one is a constant to be found, to be calculated from these conditions that you are given. So you can use this, that the first term, T1, is equal to what? To 25. So what does it mean? It means when n is 1, when n is equal to 1, Tn is 25. So you can form an equation to find C. Remember, C is to be found. You can use the second condition. This, guys, remember your arithmetic. Okay, so let us calculate C. 25 is equal to 6 times 1. That is going to be a 6. Then you can even transpose this to the other side. It will be a minus. 25 minus 6 is 19. So meaning to say Tn is equal to 6n from this one. It's 6n plus C. 6n plus 19. Remember the constant to be found. This is the relationship that we are having in terms of these rows. Row number 5, row number 4, number 5, number 6, number. So as we are at row number 100, what is the fifth number on row number 100? So the fifth number on row 100 is gonna be what? That is T100. Because this pattern that we are seeing, I mean, this formula, the relationship, it was of the fifth number. Remember, we created this out of the 50. It's already for the 50. So whatever that we substitute, it corresponds to the 50th term. to the fifth number, in that row. So that is 6 times. Remember, we are dealing with row 100. So the number that was going to correspond was going to be 619. When our n is 100 in that row, the fifth number, the number that will be in the fifth position here, as we are going down along these numbers, but in row 100, the number that we're going to have there, it was going to be 619. So this is it. This is it. Let's just hope we are together. Question number 6. 6.1. What is an algebraic expression containing 2 terms called? Just 2 terms. Remember, that's a binomial. So this is a binomial expression, just 2 terms. 6.2. What are x and y in this expression that we are seeing referred to as? Wherever you see x and y, these are letters, and letters are called variables. These are variables in algebra. All right, 6.3, simplify the following. The square root of 9x to the exponent of 4y to the exponent of 2. So we know the square root of a 9, that is a 3. But what about x to the power of a 4? When dealing or when working with the square root, to remove that square root, you divide these exponents by 2. So to remove on x to the exponent of 4, you divide by 2. So that will be x squared. On y to the exponent of 2, you divide by 2 again. That is going to be y to the exponent of 1, which is just a y. That is the idea. 6.32, these are brackets. Remember the FOIL method, expanding of the brackets x plus 5 into the bracket of x minus 3. So it follows that the x is going to multiply everything in this bracket. Okay, let's multiply x times x. That is going to be x squared to the power of 2. The x and the minus 3, that is minus 3x. We're done. So the x multiplies everything in the second bracket. Must multiply everything, okay? We move on to the plus 5. So plus 5 is going to multiply the second bracket again. 5 times x, that's plus 5x. It's a positive, that one. So that will be plus 5x. Sorry for that. Plus 5x. Again, the 5 to the minus 3. 5 times minus 3. Positive, negative. That's a negative. So it will be negative 15. So these, you are going to collect the like terms at the end. The middle term, this part, the middle terms, the minus 3x and the plus 5x, these are like terms. We are talking about the same x and the same power, same exponent, which is 1. So these are like terms. So minus 3 plus a 5, that is going to be a plus 2x minus 15, just like that. So these, you add them, minus 3 plus 5, that is going to be a plus 2. So that's it. That is your algebraic expressions. 6.32, again, simplify, but as you can see, there is a factorization to be considered. 25z to the exponent of 2 minus 9. There's a difference of 2 squares. These are perfect squares. 25 is a perfect square. So remember the difference of 2 squares, the square roots of these, square root of 25, the square root of z squared, the square root of 9. So one bracket will subtract, another bracket will add the difference of 2 squares. A squared minus b squared is equal to a minus b into a plus b. where A and B are the square roots. So we are determining the square roots of these numbers. So everything over 5z plus 3. So the 5z plus 3, the 5z plus 3 are the same. They can cancel. That's you obtain a 1. So that's 5z minus 3 times 1, which is simply a 5z minus 3. So this is what you're going to have. Remember, if you're given x over 1, it's just as x. 2 over 1 is just as 2. So this one divided by 1, it is just as 5z minus 3. 6.4, factorize fully. So what is it that you're given? There is a bracket which is common between these two, the q minus r. Q minus r is common in this part and then also on this term. So what is it that you're going to do? You simply factor out the common bracket, q minus r. If we factor out this bracket, if we remove this bracket, what are you going to remain with here? You remain with 3x. If you remove this bracket, what are you going to remain with here? You remain with minus 2. That's in another bracket. You have factorized. So to factorize is to put in brackets. To put in brackets. And it must be in simplest form. These brackets must be in simplest form. So that's it. 6.32, 6.42, we are now given again, factorize again in simplest form. So as you can see, the first thing, don't be scared about this. To the exponent of 3, don't be scared because there's also x, there's also x. So it simply means you must factor out the x, which is common. There's x throughout. That is 2x to the exponent of 3 minus 10x squared minus 28x. X is common throughout. Not just x, but also the 2 is common. So 2 is common between these two numbers, 2, 10, and 28. So we are going to factor out 2x, okay? So that is 2x cubed divided to what you factored out. So the x and the 2 and the 2, x into x to the exponent of 3. There are 3 here. So we are going to remain with 2. So that will be x squared, okay? You do the same thing with the minus 10x squared with the 2x. This was going to be minus 10x squared divided by 2x. This was going to be minus 5x. How many are there here? There are 2. So divide, you're going to remain with minus 5x. You do the same thing with the negative 28x divided to the 2x that you factored out. X and x was going to cancel. So minus 28 divided by 2, it was going to be a minus 7. So consider that, is it in simplest form? Can we factorize this quadratic expression thereafter? Okay, the highest exponent is 2. That's a quadratic expression. So this is being multiplied by 1. So we can take advantage of the 2 brackets direct. One with x, another one x. Remember, x times x. That is x squared. So what do? You consider the constant, always the constant, which is negative 7. So you're going to need the product, the factors of negative 7. Guys, how did I get a negative? This is 28 divided by 2, which is a 14. That's a 14 there, not a negative 7, guys. That's a negative 14. All right, sorry for that. So you're going to consider the product, the factors of the negative 14. But these factors must add up to a negative 5. So what are the products? Remember the products. Negative 14, 2 numbers to get a negative 14. There are so many numbers, minus 14 and 1, minus 7 and 2, 7 and minus 2, 14 and minus 1. But we need a condition where when you add, you are going to obtain a negative 5. So if you add, if you add, where are you going to get a -5? This is between -7 and 2. -7 times 2, that's -14. -7 plus 2, that's a -5. So this is what you need. So that's a -7 and a +2 in another bracket. You have factorized fully or completely. This is to factorize fully or completely. So be careful. How are you given your questions? 7.1, we are given, describe this in words. What is happening? Okay, 5 is being subtracted from x. Then it was multiplied to 3, and we are obtaining 16. That's it. So you can simply say 5, or just subtract 5 from x. Okay, 5 subtracted from a number. So x represents the unknown number. So 5 is being subtracted from this number. Then the answer multiplied by 3. Then the answer multiplied by 3. So the answer multiplied by 3 equals to 16. So the answer will be equivalent to 16 in that manner. Translate the following statement into a mathematical equation, just like what we had. We are given a mathematical equation. Now give it into a mathematical equation from a statement. The sum of half a number. So a number is always x. So the sum of half a number and 14, the sum of half a number and 4, sorry, then half a number and 4. So this is the sum, half a number and 4, doubled. So to double, that is to multiply this by 2. That is double that. Thereafter decreased by 1. Thereafter decreased by 1 to give an answer of 13. That's it. Guys, do revise as much questions as you can. 7.3, solve for x. 7.31, this is just a normal equation. Collect the terms with x to one side of the equation. So that's 0.3x minus 2, 1 is equal to. So this is equivalent to. All right, guys, you see these softwares, they need to serve this and that. So no problem. That's, you're going to take the terms of x to one side of the equation. The moment it crosses the equal sign, it must change its sign. It was a negative, so it's going to be a positive. This is 0.7. The minus 2, 1 to the other side, there is a minus 2, 1. It crosses the equal sign, it will be a positive 2, 1. So let's add 0.3 plus 0.4, that's 0.7x, which is equal to 2.8. So to find x, you can divide by the decimal 0.7 on your calculator. That was going to give you a 4. So x, which satisfies this equation, was a 4. 7.32, this is an exponential equation. 9 to the exponent of x plus 1 is equal to 1 over 27. Remember writing these numbers in the simplest form. 9 in the base of 3, 3 to the exponent of 2 into x plus 1 is equal to 27 to the exponent of -1 to remove the 1 over that you're given. But guys, 27 in the base of 3, that is 3 to the exponent of a 3, which is affected by a negative which is already there. So there's a 3 and a -1. So 3 times -1 is going to be a -3. So that's it. If the bases are the same, we do understand that the exponents will be equal. So therefore, this 2 into x plus 1 is equal to minus 3. So therefore solve. The linear equation that you're given, distribute the brackets by 2. 2 times x, that's 2x plus 2 is equal to minus 3. So you can collect the like terms, the 2 to the other side. It was going to be a negative. That's minus 3 minus 2, which is going to be a negative 5. So that's it. Divide by 2. That's a product there. So you divide to obtain the x, which was going to be minus 5 over 2 or minus 2,5. So guys, this is what we had. All this. Solve for x again on 7.33. All right. How can we solve for x? We have to clear the fractions. So given 5x minus 7 over 3 minus 7x minus 10, everything over 5 is equal to 1. So 1 is just a number which is same as 1 over 1. So you can consider the LCD of the numbers, which is the LCD of 3, 5, and 1, or the LCM of 3, 5, and 1, which is 15. 3 times 5, that is 15. So with the LCD or the LCM, to clear the fractions, you're going to multiply each and every term by that LCD. Multiply by 15, multiply by 15, multiply by 15, each and every term. So that's 3 into 15 is a 5. So as we can see, as we are clearing fractions, we are having the brackets at the end because the 5 is supposed to expand 5x minus 7. Everything is supposed to be expanded. 5 into 15, that is a 3. But there is a negative that is already there. So it's going to be negative 3 into the bracket of 7x minus 10. This is equal to 1 into 15, that is 15, times 1, which is 15. So like I said, our aim was to remove the fractions. But as you are removing the fraction, there are brackets. Distribute each and every bracket by the term that is outside of the bracket. The first bracket is affected by 5. Second bracket is affected by minus 3. So let's affect the first bracket by 5. That is 5 times 5, 25x. 5 times negative 7, that is negative 35. Negative 3 times 7, that is going to be a negative 21x. Negative 3 times a negative 10, a positive 30, which is equal to 15. So we can collect the like terms where there is x. 25 minus 21 was going to be 4x. The numbers combined minus 35 plus 30. This is minus 5, which is equal to 15. So that is 4x is equal to transpose or take the minus 5 to the other side of the equation. The moment that it crosses the equal sign, it changes its sign. It was a minus, it will be a plus. So 15 plus 5, that is 20. Let's divide. Okay, that's a product. So x, therefore, was going to be equal to 5. So guys, do revise as much questions as you can. The more questions you revise, it can help. 7.4, the square of a number added to twice the number equals 3. The number, whenever the number is not known, it's x. So the square of a number, the square of a number added to twice the number, added to twice, two times, twice the number equals a 3. Determine the possible values. It's not only a value, but there are values that can be possible for this. This is a quadratic equation, the highest exponent being 2. The format first, ax squared plus bx plus c is equal to 0. Take all terms to one side of the equation. That is x squared plus 2x. Take the 3 to the other side of the equation. The moment that it crosses the equal sign, it changes the sign. it will be a negative. So that you can properly factorize this. Remember your factorization method. Having two brackets, this is equal to 0. This is 1, so meaning to say we are going to have x and x. X times x to give us a 1. So consider the product of -3, the factors, the products that you're going to use. But these products of -3 must add up to a positive 2. If I multiply these two numbers, it's true. We are going to get a -3. But when we add, where are we going to obtain a positive 2? This one is going to give us a -2, so it's out. If we add this, it's going to be a positive 2. So this is the one that we want, which gives us a positive 2 when we add. But from the products, it must be from the products. So that's +3 -1. So these brackets that we are having, one of these to be equal to 0. That is where we are giving, or when we are having this being equal to, it means one of the brackets must be equal to 0. X plus 3 must be equal to 0, or x minus 1 must be equal to 0. So take the 3 to the other side. It was going to be a negative, or x was going to be -1 to this side. It was going to be a positive 1. So these are the possible values of the number, which satisfies the statement that we are given above. So that was a total 17 marks from this question paper. So guys, do make sure you revise as much questions as you can so that you do prepare for the exams ahead of time. But for now, that's it. Till we meet again.